Hello, thank you for watching this video. So in this video, I'll be doing question 1 to question 4 of September 2018 question paper, Mathematics paper 1 from the KZN province. So I'm doing this question as a response from a request that was made by a student that likes watching my content on this channel. So they emailed me and asked for these questions, but they only asked for question 3.2 and 4.2 of this question paper. So I decided to do all of the questions from question 1 up to question 4 so that in case she was unclear for something, she can be more happy. So let's go. Question 1, 1.1, read as follows. Solve for x. So you are given equations from 1.1.1 to 1.1.4. So on these equations, they want us to solve for x. So let's go. The first one, so we're doing question 1 now. The first question is 1.1.1. They want you to solve for x, so you have x over 2 times x minus 5 is equal to 0. So this is the first question. So they want you to solve for x. So you have this part multiplying this part. So you have x over 2 multiplying x minus 5. And the product is 0. What does that mean? If the product of the two terms that are multiplying each other is 0, at least one of them is 0. So in this case, either x over 2 is 0 or x minus 5 is 0. So in our case, x over 2 is 0 or your x minus 5 is equal to 0. Then from here you solve for your x. So your x is equal to 0 or your x is equal to 5. So this is the first one. Then we move to the next one, which is 1.1.2. What do we have there? So we have 3x squared plus 4x is equal to 2. So you are given this equation. They wanted to solve for x as well. So you are also given a hint or your instructions that correct your answers to 2 decimal places. That's what they said. So they want you to round off this to 2 decimal places. Okay, so from this instruction that say correct to 2 decimal places, I would assume they're trying to tell us that, or maybe they are also including the possibility that the solutions to this equation may be irrational. Of course, we can also have rational solutions as well that we would need to correct to 2 decimal places. But to be safe, let's use quadratic formula here to solve for this one. So, but you can apply a quadratic formula when it is on this form. So you need it in the form ax squared plus bx plus c is equal to 0. So how do we do this? Let's transpose this to the left hand side. So we have 3x squared plus 4x minus 2 is equal to 0. Right? So once we have it in this form, it resembles this part here. Then now we can start applying our quadratic formula, which is x equal to negative b plus or minus the square root of what? A squared minus 4ac, all divided by 2a. Right? Then you substitute. X is equal to negative b. What is b? It's 4. Plus or minus the square root of what? Of 4 all squared minus 4 into a. What is your a? Your a is 3. And your c is minus 2. All divided by 2 times 3. So your x is equal to, or your x is equal to. So let's punch that and see what we get. 0.39. Sorry? 0.39. 0.39 or?
Negative 1.72.
1.72. So I'll need you to double check those and be sure that these are correct. So now we'll move to the next question, which is 1.1.3. So at 1.1.3, we have that the square root of what? Of 2x plus 3, right, is equal to x. So we're given this sort of equation. Are they correct? Are you sure? Are you positive that these two are correct? Okay, no problem. So here you are given that this is equal to that. So they want you to solve for x as well. So on a normal day, you would like to isolate this so that it is on the same side alone, right? But in this case, it is already isolated. So the only thing that we do is square both sides. So what do? I say, okay, 2x plus 3 is equal to x. You square all of this and square all of that. So this and that go away. We're left with 2x plus 3 is equal to x squared. Transpose this to that side. So your 0 is equal to x squared minus 2x minus 3. Then you can factorize this. 0 is equal to, you can say you have x here, you have x here, you have 3, you have 1, you have minus, you have plus. So your x is equal to 3, or your x is equal to minus 1. That's what you have. So after doing this, you must check these values and see if they are correct. But if you look at this one, if you substitute your x equal to minus 1 there, this side is negative, but this whole side will always be positive. So there's no way that a positive side, left-hand side of this equation is equal to the negative left-hand side. So this solution, you can see that is invalid. But this one is positive, so you have 3 there. So what is 2 times 3 is 6, plus 3 is 9. Square root of 9 is 3. So this is the correct solution. So we move to the next one, which is 1.1.4. What are they saying at 1.1.4? So we are given that 9 raised x is equal to 4 times 3 raised x. This is what you're given, right? So they want you to solve for x there as well. So what do? First, find the factors of this. What are the factors of 9? 3 raised 2, all raised x is equal to 4 times 3 raised x, right?
Yes.
So you have 3 raised 2x minus 4 times 3 raised x is equal to 0. But you can see that these, you can also write it such that it looks similar to this one.
Yes.
By saying your 3 raised x all raised 2. Are you happy?
Yes.
Minus 4 times your 3 raised x. It's the same thing.
It's equal to 0.
Is equal to 0. So they look similar, right?
Yes.
Once you hear, you use the k method. You can say, okay, let's allow k equal to 3 raised x, right?
Yes.
Which means when we see our 3 raised x, we put what?
K.
We substitute k. So, which means we have k squared, which is there,
Minus 4k.
minus 4 times k, which is 4k is equal to 0. Use your quadratic equation to solve this, or you just factorize this. So you take k as a common factor, so you're left with k minus 4 is equal to 0. So either your k is equal to
0.
or your k is equal to
4.
4. Then, now you have the solutions for k. K is 0, k is equal to 4, right? So what do? We allowed our k to be equal to 3 raised x. So we can bring back 3 raised x equal to 0 and 3 raised x is equal to 4. Are you happy? But you know how this looks like. In grade 11, when you're doing functions, this is an exponential function, right? If you just look at this part on its own, this is an exponential function. Where is the asymptote of this asymptote of this exponential function? Is at at y is equal to 0. So this have an asymptote at y is equal to 0. So you know that a function of this will not get to 0. So there's no way that this solution, this is equal to 0. Because I'm saying that if you look at, let's say you look at f of x is equal to 3 raised x, right?
Yes.
This is a function, this is an exponential function. And it have the horizontal asymptote at y is equal to 0. So there's no way that this will equal to 0. So this can be a solution here. Right? And this one here, you can factor this such that it have a base of 3. Then this is where you apply the logs. So you apply the log of 3 raised x is equal to the log of 4. Right?
Yes.
And then once you apply the log, this guy comes to the front to multiply here.
Yes.
So you have x
Log 3.
log 3 is equal to log 4. Right? 3 divided by log 3. So your x is equal to, therefore, your x is equal to, punch this and see what you get. What did you get?
1,26.
It's 1 comma
26.
26. So, I believe this might be a solution. Looks like it. So, I'm done with question 1.1.1. I'm done with 1.1. I'll go to 1.2, which is simultaneous equations. I'll clean the board and then we'll go to the next question. Okay, so now we're doing 1.2. 1.2 read as follows. Solve the following equations simultaneously. So you are given this equation and this one. So they want you to solve these equations simultaneously, right? So this one is the simplest one, right?
Yes.
X is equal to 2y, right? Here's the second one. Let's say negative 4 over x is equal to y over 2 is equal to 1.5. This is 1.5, right? 1.5 is 3.5. This is 1 unit and a half. This is what? This is 3.5. So, also, if you're given something like this is a mixed diffraction, right? This is a mixed diffraction. It's 1.5. So you can punch it directly on your calculator, or you can calculate it yourself. You can say 1 times this, then you add the top one. So it's 1 times 2, then you add the top one. So it's 3 over 2. This is a mixed diffraction. It's 1 times 2 is 2, then add that. It's 3 over 2. And 3 over 2 is 1.5. So in simple terms, what you have x is equal to 2y and minus 4 over x plus y over 2 is equal to 1.5, which is 1.5 or 3 over 2. This is what you have. So you can start substituting, but for me, I would not like to substitute in something like this. This doesn't look very nice, right? I'll say, okay, I just want my x not equal to 0, right? Because if your x is equal to 0, the whole equation is undefined. Are you guys with me?
Yes.
And then after that, I'll simplify. What do I do? What do I do? I'll say, okay, I'll start with this side only. I'll say my LCD, lowest common denominator, is 2x here. This time this,
2x.
and then cross multiply. This time that,
Minus 8.
this time that,
xy.
xy is equal to 3 over 2. Are you with me?
Yes.
What do we do from here? From here, you can cross multiply, right? Which is 2x times 3, and this times the whole thing. So we have 2 times minus 8, 2 times minus 8,
Plus xy.
plus
xy.
plus xy
Plus
is equal to 3 times
2x.
2x. Are you guys with me?
Yes.
I'm not sure if you can see this, but you can rub this 2 and that 2 away. Okay, it's fine. Minus 16 plus 2xy is equal to 6x. This is what you have, right?
Yes.
And then now once you are here, and then we substitute this equation. X here and x there. Because your x is equal to 2y. So when we see x here, we'll put 2y, right?
Yes.
So we have minus 16 plus 2, which is 2y here. Y is equal to 6, 2y. Are you with me?
Yes.
Because we just substituted x there and there. So what we have is minus 16 is equal to 4y, 4y squared. Oh, sorry. Plus 4y squared is equal to 12y.
12.
Then transpose this to the side. So we have 4y squared minus 12y minus 16 is equal to 0. So we can divide by 4 throughout, or you can just plug this to a quadratic equation. Take out 4 as a common factor. So 4. So you have y squared minus 3y minus 4 is equal to 0. Right?
Yes.
So it's factorize the inner part, the trinomial in there. So you have y equal to 0. This is y here as well. So you have 4, you have 1, you have minus, you have a plus. So you have two things multiplying each other, and the product is 0, which means at least one of them is
0.
So at least one of them is 0. So it's either your y minus 4 is 0 or your y plus 1 is 0. No one cares about the 4. We know it's not 0. So your y is equal to 4 or your y is equal to minus 1. We have the y values. We need the x what? The x value. So we said x is equal to 2y. This is what we're given, is it?
Yes.
So your x values will be twice as y. Your x is equal to 2 times your y, which is 4. So your x value is equal to 8. Or your x is equal to 2 times minus 1, or to minus 2. So your coordinates is 8 and 4. The other one is what? Minus 2 and 1. Just play it 2. 2 minus 1 and minus 2. Here we go. Okay, so now we're going to do question 2. So, question 2 reads as follows. The first 4 terms of a quadratic sequence are 9, 19, 33, and 51. So you're given these terms, and you're told that they belong to a what? To a quadratic pattern. Quadratic sequence. Right? So, let's go. 2.1. Write the next 2 terms of the quadratic sequence. So they want to write the what? The next 2 terms. Easy. Find the difference. The first difference is always what? The first difference of the quadratic sequence is always what? What is it? It is an arithmetic sequence. The first difference of the quadratic sequence is an arithmetic sequence. Right? So, what's the difference?
It's 10.
Yeah. Are you sure?
Yes, it is.
Okay. And then?
It's 14.
14?
It's 18.
18. What's the difference between the two things? It's 4, right? It's 4. The next one will be what? Will be 4. Then, which means add this becomes what? 22, right?
Yes.
To be 4 again, because this one is constant.
Yes.
This
26.
26. So 51 times 51 plus 22. What is it?
73.
73. So this is our term. And then the next one, this and that,
99.
99. So these are the next 2 terms. This is it clear?
Yes.
Yes, clear. You just need to extend this, and you add this, add that, then you're done. Go to the next one. They are saying at 2.2, determine the nth term of the sequence. They want the nth term of the sequence. So this was your 2.1, right? You know, the nth term of the quadratic sequence in the form Tn is equal to an squared plus bn plus c. Is it right?
Yes.
And you know that your a, this is not 9, this is a. So you know that 2a is equal to your common difference, right? And your common difference is equal to what? 4. Then divide by 2. So your a is equal to 2. Done. This is your a. Once you have this, what do you say? You say, okay, on this Tn of mine, I only have a. Tn is equal to an squared, but n is equal to 2. So 2n squared plus bn plus c. So when you're here, you're missing b and c. What do? You say, okay, my term 1, right, is equal to 2 into 1 squared plus b into 1 plus c. So your term 1 is equal to 2 plus B plus C. Right? You know what a term 1 is. A term 1 is what?
9.
It's 9. So which means here you have what?
9.
You have a 9 here. Therefore, you transpose this to the side so that you have 7 is equal to A plus B, because if you transpose the 2 to that side, you have 9 minus 2, which is 7, is equal to B plus C. Should be B plus C. Everyone happy now?
Yes.
No problem. Do the same thing for T2. So okay, my T2 is equal to 2 into 2 squared plus B plus C. Oh, sorry. Plus B in 2 plus C, because you substitute this on a Tn, on that incomplete skeleton of Tn. So what do you do? So okay, my T2 is equal to, this is 8, right? Plus 2B plus C. What is your T2? Your T2 is equal to 19. Transpose this to the side. It becomes what?
11.
11 is equal to 2B plus C. So you have this equation and that equation. So you can solve for B and C simultaneously, or using substitution or elimination. So we don't have time for substitution because it's long. We'll use elimination. So 7 is equal to B plus C. Then subtract the 2. This minus this is 4, right?
Yes.
Is equal to 2B minus B is B. C minus C is 0. So you get that your B is equal to 4. What are you missing?
C.
Missing is C. If you take any of the two equations and substitute your B, you'll find your C. So 7 is equal to B plus C. So your 7 is equal to 4 plus C. So your C is equal to 3. Therefore, your nth term Tn is equal to 2n squared plus 4n plus 3. Done. Is it clear?
Yes.
No problem. So we move on to 2.3. What are they saying? They are saying now, prove that all the terms of the quadratic sequence are odd. Right? They are saying we must prove all the terms of this sequence are what? Are odd. What is an odd? What is it mean to be odd? Yeah.
Oh, an odd number, it's a number that can be written as 2 times k plus or minus 1.
Okay. So she's saying an odd number is a number that can be written as 2k plus 1 or 2k minus 1, right? Where your k is a what?
Element of
Is an integer. You know integers, right? Integers is the set 0, plus minus 1, plus minus 2, and so on. Those are your integers. Are we clear? So now, if they are saying the terms of the sequence are odd, right? We must show that they can be written in that form, in this form or this form, whichever form works. Are you guys with me? Okay, so now we can't show each one of these because we don't have all of the terms here. Because if you write this one, this one, this one, this one, this one, and this one in that form, it's not representative of the entire sequence. It's only representing those that are mentioned on the sequence, right? Yes. But in order to do that for all terms, you have to do it for the general term, because the general term represents all the terms of the sequence. So this Tn, you must show that this Tn can be written in that form, right? Yes. Because this Tn represents all the terms of the sequence, starting with this one. So let's go. So your Tn is equal to 2n squared plus 4n plus 3. Right? So, because I have plus 3, it's easier to have a plus 1 than a plus minus 1. Right? What I can do, I can write Tn to be equal to 2n squared plus 4n plus 2 plus 1. Because what we're trying to do without splitting this one, we decomposed this 3 into 2 plus 1 because we're trying to have something similar to this, right? So what we can do is, okay, after having that, we can group these and isolate the 1 so that it looks similar to this one. Then your Tn is equal to, take out the common factor which is 2. 2 into n squared plus 2n plus 1 plus that 1 there. This 1 comes from taking common factor out of these 3 inside that trinomial inside. Then, now, you know that for your sequences, n is a what? N is a natural number, right? Yes. And you know that your natural numbers are contained or are inside your natural numbers, your integers. Are you with me?
Yes.
So, n is a natural number, which is all of these are natural numbers, right? And the natural numbers, which is these, are inside your integers. Because the natural numbers are everyday counting numbers. 1, 2, 3, 4, 5, going forward. But look at the integers, they have 1 as well. They have 2 as well, going forward. So, this set of natural numbers is inside the integers. This is what this thing, it means inside. It's a subset or contained, right? No problem. So what I'm trying to say with this is that your n squared, which is this part inside this bracket, plus 2n plus 1, this is also a what? Is also an integer. Because you say, okay, these are natural numbers, so I'll add them and get a natural number. But that natural number that you will get will also be contained in what? In integers. And by our definition, we say an odd number is a number that can be written in this form or this form. But we have written it in this form. And this k should be what? Should be an integer. But in our case, this is our k. Right? Yes. Which is a what? Which is also an integer. So we are done with this because we have written this in that form. Or maybe if you want to be specific, you say, well, this is an integer. So your n squared plus 2n plus 1 is your k. So we have written Tn as 2k plus 1. Then we're done. Done with this question. So I'll get the board, then we'll go to question 3 that we were asked to do in the first place. But we detoured to other questions as well. So now we're doing question 3, the question that we were asked to do in the first place. So we're done with our detour, so we're going to get into real business now. So question 3, you are given that 3 minus t and negative t and the square root of 9 minus 2t are the first 3 terms of an arithmetic sequence. So you are told that these terms are the first terms of a what? Of an arithmetic sequence. So this sequence continues, as you can see. No problem. So 3.1, determine the value of t. So they want us to find the value of what? Of t. So we know, we were told that this is an arithmetic sequence, right?
Yes.
You know, what do you know about an arithmetic sequence?
T is equal to t2 minus t1.
So it has a common difference, right? Which means the difference between these two is equal to the difference between these two. So these differences are equal. So if you find the difference between this one and this one, it should be the same as the difference between this one and this one. So what is the difference between this one and this one? So it's minus t minus 3 minus t, right? Which is equal to what? This minus that, which is square root of 9 minus 2t. This is 9, not a, minus negative t, right?
Yes.
So we have negative t minus 3 plus t is equal to the square root of 9 minus 2t plus t. So these two disappear. So we're left with minus 3 is equal to 9 minus 2t plus t. So what do? You can square both sides, right?
No.
No, we isolate this.
Yes.
You need to isolate this. So we should have to transpose this guy to the other side. So what do we have? We have minus t.
Minus 3.
Minus 3 is equal to the square root of 9 minus 2t. So from here we can square both sides now. This is a 2. So what do we have? This side you have minus t minus 3 minus t minus 3, right? It's equal to what?
9 minus 2t.
This and that go away. So you have 9 minus
2t.
2t. So you do the normal thing. This time this time that. So you have t squared plus what? Plus 3t, right?
Yes.
This times
Plus
this,
3t.
this time that, plus another 3t, plus 9. It's equal to 9. Why do my lines look like this? So this and that go away, right?
Yes.
So you have t
Squared.
squared plus 6t plus 2t is equal to 0. So t squared plus 8t is equal to 0. Are you guys happy?
Yes.
Then you can take out the common factor as t. So t, you have t plus 8 is equal to 0. You have the product of two things and the answer is 0. What does that mean? At least one of them is 0. So either t is equal to 0 or your t plus 8 is what?
Equals to 0.
Which implies that your t is equal to
Minus 8.
minus 8. Then, which one do we take? So, which one do we take?
Yes.
Oh, it should be both of them. You can't really decide which one we take or not. Why not this one? Because if your t, actually, no, let's test this thing. Where do we test it? We test it, I'll say on this equation here. Right? Let's test both of these guys. If our t is 0, if our t is 0, so because this is a simplified version of this, so that's why I'm using it.
Yes, so 0 is.
So if we substitute 0, which is there, this will be 9, or it will be square root of 9 minus 0, right? Oh, 9 minus 0, which is 9. The square root of this is 3, and that is what? Is 0, which means these two cannot be equal because this side is positive, and this side is what?
It's negative.
Do you understand?
Yes.
So this is not working. The reason is because if you substitute your 3, your 0 there, this becomes 3, this becomes 0. So 3 plus 0 is 3. So this is positive, this is negative. So they can't be equal. Right? And the other one is equal to minus 8. You can test it out. It works. So we move to the next question. So we're going to do 3.2 now. So 3.2 is one of the questions that I was asked to do. So what is it saying? I'll try to be very clear on this one. So they're saying in 3.2, if t is equal to minus 8, then determine the number of terms in the sequence that will be positive. So you are given that your t is equal to what? Minus 8. So they want you to find, they're telling you that t is equal to minus 8, right? Yes. So they want you to find the terms of the sequence that will be positive. So let's develop this sequence. What is 3 minus t? So the first term is 3 minus t, which is minus 8, right? The second one is negative t. Third one is square root of 9 minus 2 t, and so on.
The first one is 11.
It's 11.
And it's
8. What is this one? Is it not 5? Looks like 5 to me.
Yeah, it is.
So these are the terms of this sequence. So what they want us to do, they're asking, they're telling you if t is equal to minus 8, right? Determine the number of terms of the sequence that will be positive. Right? They want the number of terms that will be positive. You can see that this thing is decreasing, right? Yes. So at some point it will be below 0. Yes. Right? So that's fine. What is the difference? Minus 3. Minus 3. Minus 3. So what will be this term? So it's this plus this?
It's 2.
It's 2.
Yes.
It's minus 3 is here. Minus 2 plus this?
It's minus 1.
Minus 1. So from minus 1 going, from this point going forward, from term number 5, right? Yes. Going forward, it will always be negative because it's one way, it will go down all the way. So in simple terms, it's only 4 terms that will be positive. This one, this one, this one, and that one. So you can just say only 4 terms will be positive. No problem. We can say we're done with this question. But this method works best if your sequence is positive for few terms before becoming negative. Because what if this sequence was decreasing for the first 100 terms? Sorry, what if this sequence was positive for the first 100 terms? Now you can't find all of these terms and then say it's this number of terms. So, of course, you should be creative and come up with a method of solving it for a bigger sequence, not just only this one of 4. Right? No problem. So they're asking you now, the question that they were asking you. So I'm going to do this question, but now using a slightly different method. Right? Not this counting one. So what they're asking, they're saying, determine the number of terms in the sequence that will be positive. Do you understand? So, what are the number of terms of this sequence? These are the number of terms of this sequence. Do you understand?
Yes.
Also, another question that I also mentioned in the previous question. What represents the number of terms of the sequence? It's the general term. Your Tn represents all the terms of the sequence. So what you need to find is the Tn of this sequence. And find for which values of n will that Tn be what? Be positive. I'm not sure if that makes sense.
Yes.
So, no matter what the sequence is, if they're asking you for which values of n will the sequence be positive, then you must find your general term, nth term, and ask yourself for what values of n will your sequence be positive, which is your nth term be positive. So what we need to find is our nth term. So, you know that Tn is equal to a plus n minus 1 times d. So, the Tn is equal to a. What is your a? 11 plus n minus 1 times d, which is this. So, the Tn is equal to 11 minus 3n plus 3, which is your Tn is equal to minus 3n plus 14. So, this is the general term. What the general term does, it represents all the terms of the sequence. Do you understand? Yes. It represents all the terms of the sequence. So, from this guy, which is a representative, you will ask him how many terms of his sequence are positive. Right? Yes. So you want the values of n for which your Tn is positive. What does positive mean in mathematical terms? So you want the values of n for which your Tn is greater than 0. That's where your sequence is positive. So you want values of n for which your Tn is positive. Which means you want the values of n for which your terms of the sequence are positive. So what is your Tn? Your Tn is this. It's minus 3n plus 14 greater than 0. That's all for n. Then minus 3n is equal to minus 14. Oh, it's greater than minus 14. Then divide by minus 3, divide by minus 3. Then your n is less than, because this thing changes because it's divided by a negative. What is the answer to that?
4,667.
4,67. Do you understand that? Are you guys with me?
Yes.
So, they're saying, now, what this tells you is that your sequence will be positive for n is less than 4,67. Do you understand?
Yes.
This sequence will be positive. So this, your Tn, will be positive for n is less than 4,67. But what is n? In which set is n belonging to? So n, your n is a natural number, right? And your natural numbers is 1, 2, 3, 4, 5, 6 going forward. Do you understand?
Yes.
So if your n is less than 4,67, which means it's between these two guys. It's between So in between, somewhere between 4 and what?
And 5.
And 4, between 4 and 5. Your n is somewhere in there, right? So what that means is, so your n should be less than this. So this point is in between there, between 4 and 5. But now, the n values that are less than that is this one, this one, this one, and this one. So there's only 4 of them. Which is there's only 4 terms that for which Tn will be positive. T1, T2, T3, and T4, which is what I demonstrated here at the beginning. So the simple answer is saying 4 terms will be positive. Does it make sense?
Yes.
Is it clear?
Yes.
And I hope it does make sense to you, as it does to me. So we'll move to question 4, which is the other question that we were asked to do. We're done with the detour now. So let me clear the board. Okay, so now we're doing question 4.1. Question 4, actually. So 4.1 reads as follows. Given the infinite geometric series, so we are given this, and you're told that it's an infinite geometric series. No problem. What are they saying? At 4.1.1, what are they saying? They are saying, write down the value of the common ratio in terms of x. They want you to write the value of what? Of the common ratio in terms of x. So, your common ratio, you know that is the quotient of the second term to the first term, which is equal to x minus 3 all squared all over x minus 3 to the power 1. Therefore, your r is equal to what? X minus 3. That's it. Are you guys happy?
Yes.
No problem. Move to the next one, 4.1.2. What are they saying? They're saying at 4.1.2, for which values of x will the series converge? Right?
Yes.
They're asking for what values of x will the series converge. So you know very well that if you're dealing with a geometric series, it converges if your r is less than 1, greater than minus 1. So in order for if you're working with a geometric series, it converges when your common ratio is between minus 1 and 1. But you do have your common ratio. It's x minus 3. So you want those values of x that will satisfy, such that your ratio will satisfy this condition. You want your values of x such that your series will converge. So what do? So okay, my ratio is this. So you have minus 1. In the place of ratio, you put this thing, x minus 3 less than 1. Then you solve for x transpose both sides, right?
Yes.
Minus 1 plus 3 less than x, 1 plus 3. Right?
Yes.
So we have what here?
That's
2 less than x less than
4.
4. Done. Are you guys happy?
Yes.
No problem. So now we're going to 4.2. This is the question that we were asked to do. It's the second question that we were asked to do. So let's do 4.2 and hear what they are saying. This one is interesting. So let's go. They are saying 4.2. An arithmetic sequence and geometric sequence have their first term as what?
As 3.
As 3. So, which means you have an arithmetic sequence and the geometric sequence. They have the first term as what?
As 3.
So you have the first term is 3 here, right?
Yes.
Then it continues. 3 here as well. It continues. No problem. What else are they saying? They are saying the common difference of the arithmetic sequence is p, right?
Yes.
And the common ratio of the geometric sequence is also p. Do you understand?
Yes.
In arithmetic sequence have the common difference
Yes.
of p, and the geometric sequence also have the common ratio of what?
P.
Of p. So which means here you have your d to be equal to p for the first one, and then you have your r to be what? P for the second one. Are you guys with me?
Yes.
So if I were to write the nth term of the arithmetic sequence, is Tn is equal to a plus n minus 1 times d, which is equal to what? It's equal to 3 plus what? Plus n minus 1 times d, which is what?
P.
Which is p. This is the nth term for my arithmetic sequence. Let me just write here. Just so, one thing that you need when you're doing these questions, listen to the statement and write down what you can hear. Write those bits and pieces that you hear. Because once you write them down and you can see them, they start making sense. But if you just read all of the statement, then you will have problems. Right?
Yes.
No problem. So, your geometric sequence, Tn is equal to a r raised n minus 1. Your a is equal to 3 times r, which is p raised n minus 1. So, this is how your nth term would look like for arithmetic. This is how your nth term would look like for geometric. Are you guys with me?
Yes.
No problem. Let's go. They are saying now, the 10th term of the arithmetic sequence is equal to the sum to infinity of the geometric sequence. Are you guys with me?
Yes.
They are saying what? The 10th term of this sequence, of the arithmetic, is equal to
The sum to infinity.
the sum to infinity of the geometric sequence.
Yes.
So what they're saying is that, they're saying T10, which is the 10th term of your arithmetic sequence, right,
Yes.
is equal to the sum to infinity of your geometric sequence. I've written all of the stuff that I understood from this. That's all you need to do. Once you write it down, it will start making sense. Then let's go. They say now, determine the value of P. They want you to find the value of P, which is the difference, which is the same as what? The ratio. So you know T10. You can find T10, right? Because you have the nth term to be that. So you have that Tn of yours is equal to your 3 plus n minus 1 times what?
Times P.
Times P, which is the difference, right?
Yes.
But if you want T10, it's equal to 3 plus 10 minus 1 times what?
Times P.
Times P. So your T10 is equal to what?
3
3
plus 10P.
plus 9P.
Oh, sorry.
Because this is 9.
Yeah.
You are right. So this is your T10. No problem. Which means from this I have T10. Now I need to find what? Sum to infinity. So you know that your sum to infinity is equal to A over 1 minus R. Where your R is not equal to?
0. Also 1.
Not equal to 1. Then you substitute your sum to infinity. Sum to infinity is equal to A. What is your A? 3 over 1 minus P. Are you with me?
Yes.
So you have your T10 and you have your what? Your sum to infinity. And you're told that these two are equal. So what do? You say, okay, my T10, which is what? 3 plus 9P is equal to that, which is what? 3 over 1 minus P. Are you with me?
Yes.
Then you multiply it throughout with this one. So what do you have? Or cross multiply. You have 3 plus 9P times 1 minus P is equal to 3. Are you with me?
Yes.
Or you can just multiply it throughout, then these two will cancel. You'll be left with a 3. Are you happy?
Yes.
So let's multiply this bracket out. This time this 3
Minus
minus
3P.
3P, right?
9 plus 9P.
Plus 9P,
Minus 9
9P squared is equal to
3.
3. Let's group the like terms. So this is on this and this will go away, right? And then what do we have? So you have negative 9P, right?
Yes.
Plus 6P is equal to,
Yes.
so it should be 9P squared. Then take out the common factor. I'll just take out, let's take negative 3P. You can just put it on your quadratic, negative 3P. So what are we left with here? We're left with a 3P minus 2P
No, 2.
is equal to 0. So this is what we're left with, not 2P, just 2, right? So you have two things multiplying each other. So your P is 0, or your 3P minus 2 is equal to 0.
Is
So,
that minus 3p
sorry?
equals to 0? Then minus 3p equals to 0. 3p minus 2 equals to 0.
Sorry? What are you saying?
It's okay. That is fine.
You want me to write 3?
Mm.
There's no point because it's almost because you know this one for sure is not 0. Because it's 3. So when you multiply these two, right? Are you happy?
Yes.
So now your 3p is equal to 2. Your p is equal to 2 over 3. Right? So now we have to decide now which p is correct. Is it this one or that one? So both of them are the values of p. What is p? P is the ratio, right?
Yes.
So both of those of our sequences, they are, so both of our p's, right, which is 0 and 2 over 3, are less than 1 and greater than minus 1. Are you happy?
Yes.
So now we have to decide which value of p do we select. So which one do we select? 2 over 3. Why? For me, I'll say let's take 2 over 3 and not take 0. Because if we take 0, we have a sequence like this. Of course, it will have a sum to infinity of 3, right? Which will equal to T10 if your p is 0. These two will still be equal. But you can't say, I don't think you can say it's a geometric if you cannot even forget the ratio. Because how did you identify that sequence in the first place? So I think that would be a nicer argument for it. And I hope it does make sense to you, as it does to us right now. Thank you for watching. Cheers.